Next up for section 1.2 is actually solving these equations. So to do that, we're going to use something that's really important in algebra, and it's called the zero product property, okay? And what the zero product property says is if you have some number times some other number, and you know that the multiplication, the product of those two numbers is 0, then one of those two numbers has to be 0, which I think makes lots of sense. So, for example, if you knew that one of the two numbers was 2, and you were trying to find the other number, and you knew that they equaled 0, the only thing that you can multiply 2 to get 0 with is 0. So if you know one of the numbers, then the other number could possibly be 0 in order for something to be the 0, to fulfill the zero product property. So one of those two things has to be 0. It's a product, it's a property that you're going to use a lot. So make sure that it's something you understand. If you've got two things multiplied together that is 0, one of those two things has to be 0. Okay, so that's really important. A couple of other things that we're going to use as we solve. Thing number one, look for a common factor. So look for something that you can take out. It'll make your life a lot easier. And then something else that's important, you can't ever just divide a variable out so that the variable cancels out and goes away. If a variable goes away, you're losing an answer. And if you lose an answer, then you lose possible solutions, okay? So make sure that you don't divide out a variable, and I'll give you an example here in a minute of when you could do something like that and it would not work out for you. So look for things like that. All right, in example 4, we have a bunch of things that we're going to solve. When they're asking you to solve for x, it's almost exactly the same as what we were doing in the last section. It's just that once you get your factors, they want you to actually solve and find what x equals, okay? So it's going to involve some factoring just like in the last section. So hopefully that part made sense and we're familiar with that. So here we go. So on problem A, they've got x squared plus 25 equals 10x. The only way you can solve quadratic equations is by setting them equal to 0 and factoring. So we've got x squared. I'm going to move the 10x over, so minus 10x plus 25, and that should equal 0. This should look almost exactly like what we talked about in the last section, so we should be able to factor that. So this is going to be things that multiply to 25 that add up to negative 10. So that's negative 5 and negative 5. So this is x minus 5, and I'm going to call that x minus 5 squared since we have 2 of the x minus 5s. Okay, so then I'm going to take the square root of both sides. That leaves me with x minus 5 equals 0. I add 5, so that tells me that x has to equal 5. That should be something you're very familiar with. You should have done it in Algebra 1 and in Algebra 2, so this should be very simple. Same type of deal for letter B. You notice that it's a quadratic. I also notice that they're all divisible by 2, so I'm going to go ahead and divide the 2 out as I move the 48 over. So if I divide everything by 2 and move the 48 over, this is now x squared plus 5x. 48 divided by 2 is 24, and when I move it over, it becomes negative. Okay, so again, it's a quadratic, so I need to factor it. So things that multiply to negative 24 that add up to 5 should be 8 and negative 3. So this is x plus 8, x minus 3 equals 0. So this is where the zero product property comes in handy. Notice I have one thing and two things. These two things are multiplied together to give me 0. So one of these two terms has to be 0. Well, for this term to be 0, x would be negative 8. And for this term to be 0, x would be positive 3. Again, should be something you already know, and hopefully it's something that from these factors you can recognize, oh, this would need to be negative 8. So you wouldn't have to actually write this step down, okay? That should be something that at this point you can do in your head. So I just wanted to write it down to make sure you knew where I was coming from. So this is what your answer would be for a problem like this, okay? This guy's a little different. You'll notice you've got something times something that equals 12. Well, you can't use the zero product property because the zero product property says that it has to equal 0. Well, this has to be 12. So I need to move the 12 over. But when I move the 12 over, I know that there's going to be a like term that I could subtract it from if these two were FOILed out. So I'm going to do that first. So this is x squared plus 3x plus 2x, so that's plus 5x plus 6 equals 12. And to solve a quadratic, I know that these are supposed to equal 0, so I'm going to move the 12 over. So x squared plus 5x minus 12 gives me minus 6 equals 0. Things that multiply to negative 6 that add up to 5 are positive 6 and negative 1. So again, I'm going to do this part in my head. So I know that something times something equals 0. Well, this one will equal 0 if x is negative 6. And this one will equal 0 if x is 1. Done. Okay? This one right here is one of the ones we were talking about on the last page where we said you couldn't divide out an x. So you'll see that these both have an x, okay? So what they're talking about dividing out an x, if you have 3x squared equals 4x, it looks like it would be really obvious to just go, oh, let's just divide both sides by x. That'll cancel out. That'll cancel one of those out. So 3x equals 4. Well, you'll notice here in a second that this is not going to work because it's going to lose an answer, okay? So let me show you what I mean. We said for quadratics, we have to set them equal to 0. So 3x squared minus 4x equals 0. And then we factor. Well, these two, I agree both with what I was saying earlier. They both have an x in common. So let me pull that x out. That leaves me with 3x minus 4 equals 0. So if I pull that x out to here, remember zero product property says that this thing times this thing equals 0 means that one of these two things is 0. Well, this x equals 0 is the term that I would have lost up here, because if I have 3x equals 4, I would just get x is 4/3. Well, we're missing one, so that answer would have disappeared. And then if 3x minus 4 is 0, you would add the 4, divide by the 3, so x would be 4/3. So you're going to get 0 or 4/3 on that problem. So make sure you don't divide out an x or anything weird like that, because you will end up losing an answer. All right, letter E. Same thing. Notice that they all have an x in common, but I know I can't just divide it out. So I'm actually going to move these two over here, just because I like my highest degree term to always have a positive coefficient. So this is going to be 0 equals 6x cubed minus 3x squared minus 18x. Okay? They do all have an x in common. They're also all divisible by 3. So let me divide that out. So that's going to leave me with 2x squared minus x minus 6. Okay? So now I need things that multiply to, okay, this is the kind where I like to use my method that I showed you in one of the other videos. I need things that multiply to negative 12 that add up to negative 1. Well, that's going to be negative 4 and positive 3. But notice I have that coefficient of 2, so I always divide it out. 4 divided by the 2 is negative 2, and 3 over 2 doesn't divide, and it doesn't reduce, so I'm going to use that factor. So this negative 2, let me bring down what I have. So this negative 2 right here turns into x minus 2. And this right here, the bottom number goes up and becomes the coefficient, so this is 2x plus 3. So this is 2x squared minus x minus 6 is x minus 2 times 2x plus 3. So now I have this guy times this guy times this guy. So zero product property says that one of those things has to be 0. Well, if this term is 0, x is 0. If this term is 0, x would be 2. And if this term is 0, I would have subtracted the 3 and divided by 2, so x would be negative 3/2. Okay? Negative 3/2. All right, take a look at F. F, I'm going to have to distribute this 2x in order to combine like terms. So let me do that. So this is going to be 2x squared plus 2x equals 7x minus 2. Again, it's a quadratic, so I need to set it equal to 0. So 2x squared, I'm going to subtract the 7x, gives me negative 5x, and add the 2 equals 0. Okay, I need things that multiply to 4 and add up to negative 5. Well, things that multiply to 4 and add up to negative 5 are negative 4 and negative 1. Divide by the 2. So this becomes negative 2. So these factors are x minus 2 and 2x minus 1 equals 0. Zero product property says that this one could be 2, and this one should be add the 1 divided by 2, so 1/2. All right, letter G. Ooh, this one's going to be slightly different. So I have a cube, an x to the first, an x squared, and then a constant term. So in all of the other ones we've seen so far, all of them had an x that you could divide out, but this one doesn't. But the process for solving a cubic is still the same, so we're still going to get everything over to the other side. So x cubed minus 5x squared plus 3x minus 15 equals 0. Okay? Anytime you have terms like this, you're going to want to factor by grouping. So I'm going to group these guys together, and take out whatever they have in common. So these two both have x squared in common. So if I take out the x squared, that leaves me with x minus 5. These two are both divisible by 3. So if I take out the 3, that leaves me with, again, x minus 5. These two terms, so this term and this term, both have an x minus 5. So that's my first factor. And then my other factor is the factor of the coefficient. So this is x squared plus 3 equals 0. Okay? Something times something equals 0 is the zero product property. So this times this, so one of these two things has to be 0. So if this one is 0, x would be 5. If this one is 0, well, let me show you what happens. So you've got x squared plus 3 equals 0. So I would subtract the 3, so I would get x squared equals negative 3. To get rid of the square, I take a square root. But when you take the square root of a negative, you get an imaginary number. So this would give me an imaginary answer, and I'm really only interested in the answers that are real. So this is not going to work. So I'm going to get x equals 5. Because this is imaginary, I don't care. And you'll notice in calculus, we're only going to deal with real answers. And then H, same thing. I'm going to move everything to one side. So 3x to the fourth plus 6x cubed minus 27x squared minus 54x equals 0. So let me go ahead and take out what I see that they have in common. So I know that these are all divisible by 3, and I know I can take an x out of all of them. So let me take out 3x. So if I take out the 3x, that leaves me with x cubed plus 2x squared minus 9x. 54 divided by 3 is 18. So this is minus 18. Okay, this one's a factor by grouping. So I'm going to factor by grouping within my factoring. So I'm going to keep that 3x, just bring them down. These guys both have an x squared in common. So I'm going to take out x squared. Leaves me with x plus 2. These two, I can take out a negative 9. If I take out negative 9, that leaves me with x plus 2. Okay, so then this one becomes x plus 2 times x squared minus 9. X squared minus 9 you should recognize as difference of two squares. So this is 3x, x plus 2, and x squared minus 9 becomes x plus 3, x minus 3 equals 0. So there it is factored. So I have 1, 2, 3, 4 terms multiplied together equals 0. So I should have 4 answers. This term would be 0 if x is 0. This term would be 0 if x is negative 2. This term would be 0 if x is negative 3. And this term would be 0 if x was 3. So I have 4 answers for this term. Hopefully you're recognizing the fact there's a thing called the fundamental theorem of algebra that tells you should have as many answers as the highest exponent. So whatever exponent it is, check and make sure that that's how many answers you're getting. Obviously on something like letter G, it said there should be 3 answers, and I got one that was real, and then I had a couple that were imaginary. So it's kind of a general rule for the fundamental theorem of algebra. Notice it's a theorem because you do have some exceptions like these imaginaries. And then I'm going to skip example 5. All example 5 wanted you to do was graph this on the calculator and make sure that it crosses the x-axis in these places. You can do that on your own. Hopefully this video made some sense, and we'll look at the next example here in a second.